Hi everybody, today we're going to begin talking about chapter 10, starting in 10.1. We're going to talk about circles in chapter 10. 10.1, we're going to talk about tangents to circles. So I apologize early on here. This is going to be a lot of vocabulary. Some of it you've heard before, some of it you probably haven't, but I want to make sure we're all on the same page here. So first of all, a circle. Okay, you guys probably have some image of what a circle is in your head. But we're going to define a circle as all the points if I could spell, that would be better. All the points in a plane that are equidistant, meaning they're the same distance away from, they're equidistant from a point called the center. So if you look on the right side of this page, I've got a circle in black, that outline, and then there's a point in the middle called the center. The radius, you guys have talked about these, used these before. That is the distance from the center to a point on the circle. So on my screen here, you can see it is highlighted in red, big radius. It's just how far away are these points from that circle, and they're all going to be the same there, since they are equidistant from the circle is the collection of points equidistant from that center. Congruent circles. Remember, congruent things are going to be the same size. So to tell if circles are congruent, they're going to be circles with the same radius. So same radius, they're the same size, they're going to be called congruent circles. Finally, the diameter is the distance through the center from one point on the circle to another point. So again, back to my picture up at the top on the right hand side here in blue on my screen here. I know yours are in black and white, but the distance all the way across the circle through the center is the diameter. So the key here is that it has to go through the center. If it doesn't go through the center, that's going to be something else, and we're going to talk about that here in just a second. A chord. Again, I apologize. We're going to get the vocabulary out of the way so that we can keep moving with these for the rest of the chapter. So a chord is going to be a segment whose endpoints are on the circle. So the diameter is a special type of chord because its endpoints are on the circle. However, that a chord in general does not have to pass through the center. So that's just a special trait of a diameter. So if it goes from one side of the circle to the other, that is going to be just a chord. Diameters pass through the center there. A secant is going to be a line. So it's going to extend farther than the circle on both sides. There's going to be a line that intersects a circle in 2 points. Diameter, again, I know we've already defined that. Just to reiterate the concept here, both of these definitions are good. We'll kind of use them both, so make sure you know both of these. The diameter is a chord that passes through the center. So, and I talked about that when I talked about chords, so I'm not going to spend a whole lot of time here talking about that. And finally, we're going to talk about a tangent, okay? A tangent is a line that intersects a circle in exactly 1 point. So, just so you guys have visuals of these here, PS, this is going to be a chord. PR, this is still our diameter. Okay, so those are going to take care of our chords and our diameters. Now, a secant just has to intersect it in 2 points. So line J on the right here, this is going to be our secant. And because point K, and they put this little dot here so you know that it intersects only at that one spot. I know it doesn't look like it only touches in that one spot, but it does. This is what is going to be our tangent. So, next part, we are going to tell whether the segment is best described as a chord, a secant, a tangent, or a diameter, or a radius of, and here's one thing right here. This is, designating that is circle C. So that's notation, kind of shorthand. I've kind of shown you guys those throughout the year. So AD, well, point A and D are right here highlighted in blue. So, well, it looks like it goes from one end of the circle to the other, and since it is a segment, you can tell because there's just the line over top of it. A line would have arrows on top of that. So AD is going to be a segment, and it passes through the center C, goes all the way across, so that is going to be a diameter. Segment CD looks like it goes from the center C all the way to 1 point. I would classify that as a radius. Line segment, EG. Well, line segment EG is this line right here. It looks like it's kind of on the edge there, and we've got that marking to let us know that it touches right there. Therefore, line segment EG is going to be a tangent. And we're looking for line segment HB. What color haven't I used? Red here. HB, this whole segment here. Okay. Again, it is a line segment, so it stops. It's not a line. EG was the only line we were working with. HB, it goes from one side of the circle to the other, but it doesn't pass, so that is going to be a chord. So there's kind of the first part that we want to take a look at. Next, we want to take a look at tangent circles. I promise we're almost out of words to define here. So, and it kind of just combines what we know about tangents and circles. So, tangent circles are circles that intersect in exactly 1 point. And finally, concentric. All that means is that the circles have the same center. So just some pictures down here on the left in my blue screen, or on my screen here, they're in blue. So you can have 2 points of intersections of a circle. You can have 1 point of intersection, which is going to be those tangent circles. We've got 2 types of tangents. If one circle is inside the other circle, but they still touch in that one spot, that's called internally tangent. If they are 2 circles that look like you've just smushed them together, like on the right here, they only touch on the outside, we're going to call that externally tangent. And of course, circles don't have to intersect. They can have no points of intersection, which concentric circles are probably going to have that. But as you can see here, concentric circles are really just one circle inside of another, just making sure that that center is the same point. Last thing we're going to define here is a common tangent. That is going to be a tangent between two coplanar circles. So just means coplanar, remember, just means they're on the same plane. If you're going to put them on a graph, that would be the same graph. Okay. So, we're going to tell whether the common tangents are internal or external. Okay. Big thing here. Internal, the lines intersect. External, lines do not intersect. So if I look at A, I have 2 lines, K and J here. Well, hopefully you guys can see there that they cross, they intersect. So lines J and K are internal tangents. So the way I keep that in mind, they intersect, so they're going to intersect in between the circles. So they're going to intersect inside the two on that line there. So inside internal is how I keep that straight. If I go over to B, those lines, yes, they may intersect, but they're not going to intersect in between the two circles. So lines M and N are external tangents. So again, goes back to where are they going to intersect those circles. So they're on, the circles are in between the two lines. One's on top, one's on bottom. So I would consider that the outside, if you want to think of it like that. They don't intersect in between the two circles in some point here. So those are going to be external tangents. So there's your homework. You guys can get a start on that. We will check that when I get back. If you have any questions, feel free to find me. Let me know. I'll be around. So grab me in the hall or whatever. So let me know what you need, and we'll get you squared away. Thanks.